Number 8. The area of triangle ABC is what? So this is the same triangle we've been using for the past two problems, but if you haven't been caught up, we have this triangle plotted on the coordinate plane. Point A is at -6, -4. Point B is at -2, 8, and point C is at 6, -8. And we just have to find the area. So there's two ways of doing this, and I'll show both ways. The first way is by subtraction. So I'll show you what I mean by that. So I'm going to draw a rectangle that basically covers all of the area. It's going to cover all the area of the triangle, but it's going to cover a little bit more. But I'll show you how to correct for that. So we'll have this rectangle. And anyway, you can see this rectangle has an area of, okay, so its width is 2, 4, 6, 8, 10, 12. And its height is 2, 4, 6, 8, 10, 12, 14, 16. And so the area of that rectangle alone is 192. All right, now what we're going to do is just subtract out these three additional triangles. So this triangle right here has area of 1/2 times the base, which is 4, times the height, which from 8 to -4, that's 12. So right there, that's 24. Now for the area of this triangle, so we have 1/2, and then the base is from -2 to 6, so 8. And then the height from 8 to -8, that's 16. So that's an area of 64. And then for this bottom triangle, from -6 to 6, that's a base of 12, and then we'll have a height of 4. So that right there, that's going to be 24 as well. So adding all these together, 24 plus 24, that's 48, plus 64 is 112. And so then we take the full rectangle area, subtract out the areas of these triangles that we don't want. You get 192 minus 112 equals 80.0. And that's answer choice D. All right, now I'll show you the other way. And actually, while I was talking, I thought of a third way that I'll show you just in case it comes in handy. All right, the next way to do this problem is with what's called the Shoelace theorem. And here's what you do. So I'm going to start with point A. And here's point A, so -6, -4. And then I'll just go around the triangle. So point B, that's -2, 8. Point C is 6, -8. And then I'm going to go ahead and write point A again at the bottom. And this is just the setup. So if you want to find the area of the triangle, first thing you do is you take these diagonals. So first you go from top to bottom. Or sorry, top to bottom going left to right. So I have -6 to 8, -2 to -8, and 6 to -4. So what you do is you multiply all these and add them all together. So -6 times 8 is -48. -2 times -8, that's +16. And 6 times -4, well, that's -24. Okay, now what you do is you go the other way. This is why it's called shoelace theorem. You see these crosses kind of make a shoelace pattern. So now our other ones will be -4 times -2, which is +8. And then 8 to 6 is 48. And then -8 times -6, that's another 48. So whenever we add these together, -48 plus 16 is -32. And then minus 24, that's -56. And then 8 plus 48 plus 48 is going to be 104. So what you do next is you take these two numbers and you subtract. Doesn't matter what order, because we're going to take the absolute value in the end anyway. So if I do 104 minus a -56, that's the same thing as 104 plus 56, so that's 160. And then divide that by 2. you're always going to divide that by 2. So you get a final answer of 80, which is the same thing we got as before. Now for the third way, which is probably the easiest way. This is called Shoelace theorem, by the way. The third way, which is probably the easiest way, is called Pick's theorem. Pick's theorem. And all you have to know for this is just the number of boundary points of your shape and the number of interior points of your shape. And this is a formula or a theorem for finding the area of any polygon on like a lattice grid like we have here. So Pick's theorem says that the area in square units, that's important, the area in square units will equal the number of boundary points divided by 2 plus the number of interior points and then minus 1. So we just have to count the number of boundary points, number of interior points. So how many do we have on the boundary? We have, all right, so we have 1, 2, 3, 4, 5, 6, 7, 8. So we have 8 boundary points. Well, how many interior points do we have? This is going to be a little bit more, but so we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17? Yes, 16, okay, so 17 interior points. And now we just plug it into this equation. So our number of boundary points divided by 2, that's 4. And then plus the number of interior, that's 17, and then minus 1. And that gives you an area of 20. And you may be thinking, well, that's 20, and our answer is 80, so like, what gives? Remember, Pick's theorem gives you the area in square units. And if you'll notice, each of these square units is a 2 by 2 square. Or, in other words, each box is going to be the same thing as an area of 4 because it's 2 by 2. So we just take this and multiply by 4 to get us to our 80. Once again, we get this answer. So that's 3 ways to do that question. It's up to you which way is easiest, but Pick's theorem is pretty nice in my opinion. Anyway, if you have any questions from other tests, make sure to leave a comment and I'll make a video with a solution. With that said, if you enjoyed the video, leave a like and subscribe, and I'll see you next time.